Video we're going to continue section 3.2, polynomial functions and their graphs. And we're going to start this video by talking about the zeros of a polynomial function. If f is a polynomial function, then the values of x for which f of x is equal to 0 are called the zeros of f. These values of x are the roots or solutions of the polynomial equation f of x equals 0. Each real root of the polynomial equation appears as an x-intercept of the graph of the polynomial function. So the zeros of a function are just where we cross the x-axis. Again, our output, our values are on the y-axis, 1, 2, 3, 4, and then negative 1, 2, 3, 4. If our y value is equal to 0, that means we are on the x-axis. And you know, some of these points maybe we'll cross the x-axis or maybe we'll touch the x-axis and then turn back around. But setting the function equal to 0 shows us the roots or the solutions or the zeros of that polynomial. Well, let's see here. Find the zeros of this polynomial function f of x equals x cubed plus 3x squared minus x minus 3. Well, to find the zeros, we set the polynomial equal to 0. And our usual method of attack is to factor. Can we factor this? Well, let's see, it's got 4 terms. The highest power is third power. That should be a clue that this should be a factor by grouping. Let's see, out of the first group, I can pull out an x squared, and then that'll leave in the parentheses x plus 3. Now here, it's minus x minus 3. Remember, there's an implied 1 in there. Let's factor out a negative 1. If we factor a negative out, that changes this negative x to a positive x, and it'll change this negative 3 to a positive 3. Aha, look at that. So one of our two factors is going to be the repeated x plus 3, and our other factor is, of course, the leftovers, x squared minus 1. And that x squared minus 1, hopefully you'll see that, is a sum and a difference. X plus 1, x minus 1, and x plus 3, all multiplied equals 0. Remember our zero product property. We set each of these separately equal to 0. If x plus 1 is 0, x is negative 1. If x minus 1 equals 0, x will equal positive 1. And if x plus 3 equals 0, x equals negative 3. There are the 3 zeros of that polynomial. And here's our graph. So we found negative 1, negative 3, and 1. Well, here's our negative 3 x-intercept, our negative 1, and our positive 1. And the graph, notice, crosses at each of those x-intercepts. Okay. On the old graphing calculator, let's see here, graphic and numeric connections. A graphing utility can be used to verify that negative 3, negative 1, and 1 are the zeros of this polynomial that we just found in that last example. Numerically, you would punch this equation, of course, into the y-editor. That'd be the green diamond F1 key. And you'd plug in the equation, hit enter, and then you could go to the table. Here is a column of x values, here's a column of y values. If you scan the y values, you'll notice 3 zeros there. And the x values that those occur at are negative 3, negative 1, and 1. You could also check graphically. Display the graph with the calculator. The x-intercepts show those zeros. All right, example 6. Find the zeros of this polynomial. All right, negative 4x, or negative x to the fourth plus 4x cubed minus 4x squared. Let's see, we can pull out an x squared. And why don't we pull a negative out with it? Why not? Pull out a negative x squared. So we pull that out of the first term, leaving an x squared, positive. We factored out a negative, so this sign will change. We didn't factor out any coefficients, so the 4 is still there. And we factored out an x squared from an x cubed. That leaves an x. Again, we factored out a negative, so the sign changes. The 4 is a constant. We didn't factor any numbers out. And the x squared was factored out in its entirety. Okay, and we want to set this equal to 0. Here we have another trinomial. Is that factorable? X squared minus 4x plus 4. Well, that looks like x minus 2 and x minus 2 equal to 0. And just because it's going to be a little more relevant in a minute, I'm going to write x minus 2 times x minus 2 as x minus 2 quantity squared. All right, set each of those values equal to 0. Negative x squared equals 0 at x is 0. And x minus 2 equals 0, we would add 2 to both sides and get x equals 2. So there are the two zeros to this function. Let's see what the graph looks like. Aha, a little different. Now look at this. We did not cross the x-axis at 0 and 2. We only touched them and turned around. Now let's back up. Here, we crossed the x-axis. We didn't just touch it and turn around. We actually went across from positive to negative territory. What's the difference in our roots? There is a way to tell, if we cross the x-axis or if here we touch it and turn around. If I back this up, notice here, each of our roots had a squared. This was negative x squared, and this was x minus 2 quantity squared. We call this the multiplicity of the zeros. So if the multiplicity is 2 or even, we are just going to touch the x-axis and turn around. On the other hand, here our multiplicity of each of these terms, these are all first power, and they were all different numbers. So when it is a first power or any odd power, back that up. Again, multiplicity, odd, that means we cross the x-axis, not just touch it and turn around. And that's what we talk about here in the next section of your notes. We can use the results of factoring to express a polynomial as a product of factors. For instance, in example 6, we can use our factoring to express the function's equation as follows. And here we have our negative x squared and x minus 2 quantity squared. The x factor occurs twice. X squared is x times x. And this x minus 2 factor also occurs twice. Note that each factor occurs twice. In factoring the equation for the polynomial function f, if the factor x minus r occurs k times, but not k plus 1 times, we call r a 0 with multiplicity k. For the polynomial function f of x equals, and here was our terms from the last example, 0 and 2 are both zeros of the function with multiplicity 2. Multiplicity provides another connection between the zeros and the graphs. The multiplicity of 0 tells us whether the graph of the polynomial function touches the x-axis at the 0 and turns around, or if the graph crosses the x-axis. For each example, look again back to the graph of figure 320, and we looked at that in an earlier example. That was one where the last one we did. Each 0, 0 and 2, have a multiplicity of 2. The graph of f touches but does not cross the x-axis at each of those zeros of even multiplicity. By contrast, the graph crosses the x-axis at odd multiplicities. So if r is a 0 of even multiplicity, then the graph touches and turns around. If r is a 0 of odd multiplicity, the graph crosses the x-axis. Regardless of whether the multiplicity of 0 is even or odd, the graphs tend to flatten out near zeros with a multiplicity greater than 1. So, if a polynomial function's equation is expressed as the product of linear factors, we can quickly identify the zeros and multiplicities. So here in example 7, our polynomial is already given in factored form. So find the zeros and their multiplicities here. Find the zeros of this function. And I'm just going to copy it again here. F of x is a half, and then we have quantity, x plus 1, and then quantity, 2x minus 3 squared. State whether the graph crosses the x-axis or touches and turns around at each 0. So let's see. Here's our first 0. X plus 1 equals 0 at x is negative 1. If I subtract 1 from each side, I get x is negative 1. This had multiplicity 1. Our multiplicity was odd, and that implies we're going to cross the x-axis at 0, or excuse me, at negative 1. Our other factor, let me switch over to blue ink, 2x minus 3. 2x minus 3 equals 0 at, well, let's see, we would add 3 to both sides and then divide by 2. X equals 3 halves. At positive 3 halves, we have a multiplicity of 2 because this was a squared term. So that means we're going to touch and turn. We're not going to cross. Not cross. That's terrible. Not cross. Touch and turn. Touch and turn around. Okay, so we know at negative 1 we have a 0, and at, this would be positive 1 and then positive 2, so 3 halves would be right about here. So there are our zeros. At negative 1, we're going to cross the x-axis. At the other one, we're going to touch and turn around. Well, let's see what else we can figure out here. What about our end behavior? Let's see, what power is our function? It's third power, odd, and our leading coefficient is positive. Positive and odd means up to the right and down to the left. So let's see, we're going to be going up to the right and down to the left. Let's see if we can get a flow of the graph. Well, we know we're going down this way, and we cross at negative 1. I guess we can find our y-intercept, can't we? Yeah, let's find our y-intercept. Plug a 0 into f of x. So here's going to be 0 plus 1 times 2 times 0 plus 3. So we're going to have a half times 0 plus 1 is 1, 2 times 0 is 0, plus 3 is 3. And if we multiply those together, we get a half. So we cross our y-axis at 1/2. All right, we were again going down to the right. That's our end behavior. We know we cross at negative 1, and then our y-axis is intercept is here. And then we're going to come down, and here we do not cross, but we touch and turn around, and then we're up, completing our end behavior up to the right. And I guess we did go a little far. They didn't ask us to graph it. They only wanted this stuff. Where are the zeros, and what can we tell about the multiplicity, and does that mean we're going to cross or touch it and turn around? Okay, some for you to try on your own. Find the zeros, and then state the multiplicity and what that tells us about the function. So pause the video and try those out. Fire it back up and see if you got them right. Okay, for the first one, find the zeros means set it equal to 0 and factor. X cubed plus 2x squared minus 4x minus 8 is equal to 0. Again, it's cubic, it's 4 terms, so factor by groups. Let's group off the first 2 terms and group off the second 2, and note we are minusing there, so we got to be careful with our signs. Factoring out a negative. Factor an x squared out of the first term, and then we're going to be left with x plus 2. And we'll factor a negative 4 out of the next term. And if we factor out the negative, it'll change us to a positive, and factored out the 4, so it leaves the x. We factored out a negative, so this sign will switch. And we factored a 4 out of 8, which leaves a 2 in its place. Okay, so we do have 2 factors. One of them is the repeater. Do not confuse this with the multiplicity of a factor. This is x plus 2 is just one of our factors, and the other is the leftovers, x squared minus 4. Ooh, and that is a difference of squares, which factors to a sum and a difference. X plus 2, x minus 2, and then we have this again, x plus 2. So let's write it with multiplicity a little more obvious. The x plus 2 term is quantity squared, because we have 2 of them. And then we have x minus 2. So there's our zeros. X is going to equal positive 2, and x will equal negative 2 are the zeros of the function. Okay, here's another one. It's a 4th power, but it's still the same setup, find the zeros. So we're going to set it equal to 0, and let's see what we can factor out. Just an x squared looks like, and that'll leave an x squared minus 4 equal to 0. And again, we have a difference of squares, so that'll be a plus 2 and a minus 2. So here we have a 0 at x is 0, and they're not asking us for it, but that's multiplicity 2. So we know there we're not going to cross the x-axis. And then here we have a pair of zeros at plus and minus 2. Plus and minus 2, and those are both of multiplicity 1. So at those zeros, we will actually cross the x-axis. Last one here, 7. And if we got time, let's sketch a little graph of it. Why not? Find the zeros of this, give the multiplicity, state whether it crosses or touches. Okay, well, if we look at this first factor, we can set that equal to 0. X plus a half equals 0. We would subtract a half from each side. So x is minus a half. That's a 0 of multiplicity 2. And that tells us we're going to touch and turn. We're not going to cross the x-axis. Our next factor is x minus 5. Set that equal to 0. Add 5 to both sides. X is 5. And this is of multiplicity 3. Odd multiplicity means we're going to cross the x-axis. Okay, again, if we do have time, this is really a lead into what we're going to do tomorrow in class or in the next video. But we have some factors or some zeros at negative a half and positive 5, and we're not to scale here. And let's see, we have a negative leading coefficient, and it's an odd power. Negative, odd power. Our end behavior is up to the left, down to the right. So it's going to be up to the left, down to the right. And let's see, at 2, or at negative a half, we touch and cross, or I mean touch and, touch and turn. Why did I write touch and cross? Touch and turn around. So here we're going to touch and turn around. We're going to hit the negative a half, turn around. We could find our y-intercept, but let's wait for tomorrow to do some more with that. We know we're going to cross at 5, and then we're headed down. So there's a rough graph, rough sketch of the graph. All right, homework for tonight, page 361, 25 to 32. If you do not have your book with you, you can just pause the video right here and copy the problems down. There you go. Make sure you read the directions also, and give the answer to everything that the directions are asking for.